Hello class, welcome to this day 3 midterm review. So this review covers parallel and perpendicular lines. So we're covering the activity that we did on this day. So let's go ahead and get started. So the first question is, what is the equation of a line perpendicular to the given line that passes through a given point? So here the given point is provided, and it's -4 and +2 for the coordinates. Now remember, for the equation of a line, you need a point on the line, and then you're going to need some kind of slope. And so in order to figure out the slope of this line that's going to cross us at a right angle, we need the slope of the original line. So we need to do a rise over run. So we're going to figure out the slope. In this case, this graph runs a distance of 5, and it rises a distance of 10. And so the slope of this line is 10 over 5, which is 2 over invisible 1. And then if I want to figure out the perpendicular slope, then I'm going to have to flip this, do the reciprocal, and then change the sign. So it's going to be -1/2. So that's going to be the slope of the new line that crosses this point, that crosses this at a right angle. Okay, so we got ourselves a slope and a point. We can find the equation of the line by using the slope-intercept form. Do that over here. So we get y equals mx plus b. Let's replace m with the slope that we found, -1/2. Then we're going to use our x and y coordinates here. So we got y is +2, x is -4. And then we do the math here. We got 1/2 of 4 is 2. And then so we're left with 2 is equal to 2 plus b. And subtract 2 on both sides leaves us with b is equal to 0. And so that means that this b value here, the y-intercept, is 0, which means that this goes away essentially, because the 0 doesn't really do anything. And so our final equation is y equals -1/2x. Okay, so that's going to be the solution to this problem. And you notice that if I were to draw a line with that slope, well, you're going to start here, and then you're going to go up 1 over 2 this way, up 1 over 2. And you have a line that looks sort of like that. And that crosses this at a 90-degree angle. That's how it would look like if you graphed a line. All right, so let's do the next question. Well, and that question actually matched this answer, and so we'll do this question next. What is the relationship between the two lines given in standard form? So we're going to have to convert these from standard form to slope-intercept form. So let's go ahead and do that for this first one. So in order to convert it to slope-intercept form, we need to solve for y. So I'm going to get rid of the 6x first. Bring down the -y. You can't combine these together because they're not like terms. Remember, like terms are when you have the same variable, right? So in this case, this does not have an x. This is a constant right here. So we can't combine them. So we're going to just simply write them as such, like this, as a sum. And then what I'm going to do is I'm going to switch this to a positive sign because I want it to be positive. But if I do that, I need to change all of these by their opposite sign. And so I'm going to change this +3 to a -3. And now we have our slope-intercept form right here, -6x minus 3. So now I will go ahead and solve the next equation. I have x minus 6y equals -2. Let's go ahead and get rid of this 1x here. I'm going to subtract it on both sides. Again, these terms on the right-hand side are not like terms, so I can't simply combine them. I'm going to bring down this -6y. Let's bring down the -x and then bring down the -2. Now this is multiplying, so I need to get rid of this -6 by dividing everything by -6. Negative 6 divided by negative 6 is 1. So this leaves us with 1y. There's an invisible 1 here. These become positive. These become positive. So you're left with 1 over 6x and then 2 over 6. And 2 over 6 is the same thing as 1 over 3 because you can reduce that fraction by dividing by 2. So we're left with 1 over 3. Okay, so we got our two equations, and so notice that the slopes of these equations are negative 6 and 1 over 6. So if we compare negative 6 with 1 over 6, we can see that if I flip this, it's going to give me 1 over 6, and that these signs are opposites. One is positive, one is negative, and hence these lines are actually perpendicular. Okay, so let's go to the answer that says perpendicular. That's this one right here. This is our next problem. So let's see. It says what is the equation of a line parallel to y equals negative 2x minus 5 that passes through the point with negative 1, 4. So we want a line that is parallel, which means the slope has to be the same. The slope of this line is negative 2. So we know that the slope is equal to negative 2, and that's the same thing as the slope of the parallel line. And we have a coordinate x and y. So we can go ahead and write down the slope-intercept form of a line. We know that this m is equal to negative 2, so I'm going to replace that first. Next, I'm going to replace x and y, so that means y is going to be 4, x is going to be negative 1. Negative 2 times negative 1 is 2, so we have 2 plus b, and you can kind of see here b is going to be 2 because 2 plus 2 is 4. In any case, we can subtract 2 on both sides and get the same result. So we got b is 2, and then this means we're going to replace this b with a 2. So our final equation is y equals negative 2x plus 2. Okay, so let's go ahead and use that equation we have right here. So that equation answers that question. So what is the equation of the perpendicular bisector of the segment below, of the segment given? Now they want two things here. They want perpendicular and they want a bisector. Bisector means cut in half. So that means we need to find the midpoint. So we need to find the midpoint of this line segment, and we need to cut this in a 90-degree angle, which means we're going to need to find the slope. So let's find these 2 points first. So this point on the left is given by negative 2 and 3. That's because this is going 1, 2, 3. That's 3. So negative 2, 3. And this coordinate here is 4, 0. So now let's find the midpoint of these two coordinates here. So remember the midpoint. To find the midpoint, you have to average the x and the y's together. So we're going to add the x values together, divide by 2. Then next we're going to add the y values together, divide by 2. So negative 2 plus 4 is 2. 2 divided by 2 is 1. This is going to be 3 divided by 2, which is 1.5. So my midpoint is 1 and 1.5 right here. So that's my midpoint. Okay. Now let's go ahead and find the slope of this line. So how much does it rise? Well, in this case, this line drops 1, 2, 3. It drops 3. So it's a minus 3 there. And it runs 1, 2, 3, 4, 5, 6, and it runs 6. This means that the slope is equal to minus 3 over positive 6. So that means that you can reduce this actually. We can divide this by 3, and this gives us a slope of negative 1/2. Okay, which we'll call m. Now we want the perpendicular slope to this. Remember, it says they want a perpendicular bisector, right? So that means we're going to need to find the perpendicular version of that. Remember, to do so, you need to find the reciprocal, flip this fraction, and then change this from a negative to a positive sign. So it's going to be positive 2 over 1. And 2 over 1 is the same thing as 2. So we got a slope of 2. We're going to be using this as our slope here. So now let's officially find the equation of the line. Y equals mx plus b. The m that we're interested in is this m perpendicular, okay? So we have y equals 2x plus b. Now we plugged in our slope of 2. So now we're going to plug in these coordinates, x and y, the midpoint that we found earlier. So y is going to be 1.5 equals 2x plus b. We know that x is equal to 1, so I'm going to replace that with 1 right now. 2 times 1 is 2. So we have 1.5 equals 2 plus b. We'll subtract 2 on both sides and get negative 0.5 is equal to b. So b is negative 0.5, which is the same thing as negative 1/2. So b is negative 1/2. So our final equation is going to be y equals, we'll put it over here, 2x minus 1/2. Let's go ahead and match that up with one of the cards here. So it looks like it matches up with this one. Graph the equation for the answer of the previous problem. Which of the following points lies on the perpendicular bisector? So we went ahead and we already found this equation, so now we want to graph it. Let's graph it in the previous problem. So I'm going to go ahead and erase all these, and except for the 0.1, 1.5. And then we'll go ahead and, since they want us to graph it, so we got 2x minus 1/2. How do we graph 2x minus 1/2? Well, we know that the y-intercept is negative 1/2, and so we can easily plot that. So that's going to be negative 0.5. The y-intercept, remember, is where it crosses the y-axis, and this is the y-axis going up and down, and so it's going to cross this y-axis at negative 1/2, so at this point right here. And then the slope is 2, which means it's going to go up 2 for every 1 to the right. So we got 1, 2, and then every 1 to the right. And so we have this coordinate right here. But we already knew that that was going to happen because that was the midpoint. Let's go ahead and find some more points here. 1, 2, and then 1 to the right. And then we'll do this down here as well. 1, 2, 1 to the left this time so that we can make our line. And that's how our perpendicular bisector looks like. And we can see that it cuts this at a 90-degree angle, and it cuts this in half, which is the whole point of a perpendicular bisector. Now let's go ahead and see which of these points belongs here. 1, 2, is that one of our points? Let's go ahead and look at it. We have 1, and then not 2, 1 and 1.5, so that doesn't make sense. So we're going to cross that one out. That's not true. 2 and 3.5, is that going to be true? Let's see here. X coordinate of 2, and then 1, 2, 3, 3.5. That looks like 3.5 to me. So this is 2, 3.5. So that looks like a check. Let's double check the last coordinate just to be on the safe side. Negative 2 and 3. So negative 2, 1, 2, 3. No, that's this coordinate right here. So that's not correct. Okay, so we found our answer. It's going to be 2, 3.5. So we got this coordinate here. What is the equation of a line perpendicular to the given line that passes through the given point? So again, we have a coordinate. Let's find the coordinates there. That's going to be 1, 3. And we want it to be perpendicular. So, and they don't care about it being a bisector or anything like that. They just want a line that is perpendicular. Okay, so let's find the slope of this blue line so that we can find the perpendicular version of that. So the slope is, it's going down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it's going over 1, 2, 3, 4. Oh, actually, it doesn't look like it's going over 4 exactly. This is not a very good indicator. I can't tell where that belongs, right? So therefore, what I'm going to do is I'm going to choose another set of points. I know that this is a good point, but this is not exactly at the 1 here, right? It's not exactly at the 1. It's just before the 1. So that's not going to be very good. Let's choose another point. Let's choose a point like this one. This one is directly on there, so we should be able to find it. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. And then, so that's down 8, and then 1, 2, 3 over 3. That's better because it's exactly on the graph and on the coordinate here. So the slope here is, it's going to be, the slope here is negative 8 over 3. And according to this equation, according to this problem, we want perpendicular. So let's go ahead and change this to the perpendicular slope. We're going to flip this fraction, again, the reciprocal, and then change the sign from a negative to a positive. So this is a positive 3/8. Now we got x and y because we got a coordinate and we got a slope. So we should be able to plug that in. Y equals mx plus b. We have, so let's plug in the slope, y equals 3/8 x plus b. Now let's plug in x and y. Y equals 3/8 times x is 1 plus b. So we have here 3/8 times 1 is 3/8. So we have 3 equals 3/8 plus b. So to find b, we need to subtract 3/8 on both sides. This one requires a little bit more work because we have a whole number with a fraction. So let's go ahead and do that real quick. Let's do the math here. So this is what b is equal to. We got to subtract those. So put this over an invisible 1, and then don't forget to combine to get a common denominator. Common denominator here is 8. So I'm going to multiply this by 8, top and bottom. Get 24 over 8 for this side here, minus 3/8, which is going to give us 21/8. So that's going to be my fraction. That's my b. b is 21/8. So I can replace this with 21/8, left with y equals 3/8 x plus 21/8. Let's double check that to see if that makes it. That's actually one of the solutions here. Looks like this solution here. So let's go ahead and finish this problem up. What is the relationship between the two lines given in standard form? Again, we're going to have to convert these to slope-intercept form. So let's take the first equation. Need to get rid of this 5x, so I'm going to subtract 5x on both sides. Bring down this negative y. We have negative 5x minus 3. Let's just bring this down because we can't combine them. Let's again switch this to positive, and then we'll switch these to their opposite signs as well. So positive, positive. So we got y equals 5x minus 3. That's not the answer. I'm just going to circle it instead of box it. Now let's go ahead and do this last equation. Again, doing the same thing. Let's subtract x on both sides. Bring this down. Negative 5y equals, can't combine those, bring them down. Negative x minus 20. Let's divide everything by negative 5 to get rid of it. So we got negative 5 here, negative 5. So now there's an invisible 1 here, negative 1 over negative 5. 2 negatives is a positive when you divide. So we get 1x over 5. This is another 2 negatives, that's a positive. 20 divided by 5 is 4. So we got our two equations. We can tell that this is 1/5, this is 5. So we got a positive slope here and then another positive slope. So let's compare those. 5 versus 1/5. So 5 is definitely the flipped version of 1/5 because if I flip 5 over 1, I get 1 over 5. However, they're not opposite signs. So one is positive and the other one is also positive. So these are not perpendicular. So let's see here. So in this case, they're not perpendicular and they're not parallel because parallel means that they have the same slope. This means that this is going to be neither. So we're going to find one that's neither parallel nor perpendicular, which is going to be this one. Okay, so let's see what we have so far. We still got a few problems left. So it's neither in this case. So we're going to answer this equation, this question here. What is the equation of a line parallel to this? So slope here is negative 5/3, and we want it to be parallel, which means same slope. So we'll call this M parallel. passes through the point, we got x and y. Let's go ahead and plug it into y equals mx plus b. So let's plug in the m parallel here. Now let's plug in x and y. So we got y is 4, x is -3. Remember, put this over an invisible 1, multiply straight across. So 5 times 3 is 15, and that's going to be positive because 2 negatives. 3 times 1 is 3. 15 divided by 3 is 5, so we get 4 equals 5 plus b. We'll subtract 5 on both sides. So 4 minus 5 is -1. So b is -1. We can replace it here. We get our equation, -5/3 x minus 1. Looks like we got this one here. Now, what is the equation of the perpendicular bisector of this segment given? Again, so we have a perpendicular and we want to do a bisector. So let's find the coordinates here. Coordinates of this are 1, -5. This one is 5, -1. Let's go find the midpoint between those first. So the midpoint, remember the midpoint is when you combine when you add the x values together, divide by 2. So we got 5 plus 1, divide by 2. Then we got the -1 plus -5, divide by 2. So 6 divided by 2 is 3. -6 divided by 2 is -3. So that's our midpoint. All right, so next, we want to find the slope here. So how much does it rise? So it looks like it rises 1, 2, 3, 4. So +4. And then it runs 1, 2, 3, 4. So it looks like the slope is 4 over 4, rise over run, which is 1. Now, 1 is the same thing as 1 over 1. So now we'll flip it to find the perpendicular and then change the sign. So the perpendicular is going to be 1 over 1, change the sign to -1. And -1 over 1 is the same thing as -1. So I'll just write it as -1. All right, so we got our slope and we got our coordinates. Let's combine those to get into the y equals mx plus b. So the slope is -1. Combine our coordinates here, -3 for y, 3 for x. So we'll go ahead and add 3 to both sides here. So b is 0. All right, so that means that this right here is 0, which means it really goes away. So it's really not doing anything to the equation. So our equation is y equals -x. Okay, graph the equation for the answer to the previous problem. Which of the following points lies on the perpendicular bisector? So let's go ahead and graph it. It's not hard to graph it. It's only y equals -x, right? So the slope is -1 and the b is 0, which means that it crosses the y-axis at 0. So it's going to cross right here. And let's use another color there. And the slope is -1, so that means you're going down 1 over 1. Down 1 over 1, and so on. Pretty easy equation to graph. So that's our perpendicular bisector, cuts that at a 90 degree, and it cuts this in half. All right, so now let's see which coordinates agree with that line. So we got 3, -1. We got 3, -1. That's not right. 1, 1, that looks good because 1, 1, actually it might not be right because 1, 1 is over here, so that's not right. What about -1, 1? That's -1, 1, that's this point right here. So yes, that checks out. So that's our solution, -1, 1. All right, agrees with that card. And looks like we're wrapping this up here. We got 2 more problems. Identify the relationship of the 2 lines. So you can clearly see from this equation that the slope is -4, so there's no need to solve that. It's already in slope-intercept form. Now this equation, let's rewrite the bottom equation and solve it. We want to solve for y, get y by itself. So let's get rid of this 2 by adding it to both sides. You can't combine those, so just bring them down. All right, now that's in slope-intercept form. You can see here that the slope here is also going to be -4. If the slopes are the same, that means the lines are parallel. All right, we're down to our last question. Identify the relationship of the two lines. So in order to solve this one's already in slope-intercept form, so there's no need to solve that. Slope is 2. Now let's do this one. All you got to do is get rid of that 2. So I'm going to divide everything by 2, and then that gets y by itself. That's what we wanted. 4 divided by 2 is 2. 6 divided by 2 is 3. So it looks like not only is the slope the same, it looks like the line in general is the same. So they're on the same line. That means they're neither parallel nor perpendicular. They're actually the same line. So it's going to be neither for that for this example because they're actually the same exact line. All right, guys, I hope you found this video useful. And as usual, I'll see you in the next one.